Hello friends, welcome back. In this session, we will clearly understand the importance of text preprocessing for NLP applications. We will also give you the sample codes and how do we do this kind of text preprocessing for NLP applications through this session. It's going to be very simple, easy to try, and you can use Google Colab to try out all this. So, a complete learning of text preprocessing for NLP applications will be taught in this session. It's going to be easy. Why do we need pre-processing? First of all, for any AI task, take any AI task, pre-processing is very important. When it comes to NLP, it is going to be text pre-processing, which is very vital. It helps in removal of the unnecessary data from the large corpus that you have collected. This helps in also removing the huge amount of ambiguity that the data which is not right will bring into the table. More accurate data can be really gotten into picture when you go ahead with text pre-processing. Unnecessary data is a pain and that adds a lot of complexity to the entire process, and we could avoid that with text pre-processing. The computational complexity will be definitely reduced when you go ahead with text pre-processing. We are going to learn the simplest of the text pre-processing techniques, and it's going to be really helpful. You can try it out yourself with Google Colab, and that's pretty easy for you. Let's go ahead with it. First, we have to install the NLTK toolkit, which is nothing but natural language toolkit, and it can be installed in one go. You can see that I have installed it with 5 lines of code, and additional packages have been downloaded that will help you at a later point in time. Pip install NLTK, import NLTK, that's it, it's done. I have downloaded PUNKT, WordNet, stopwords. That's it. We are going to use all these in the examples, and that way we will find it very comfortable. Right? So, we have to install the NLTK first. This is to be done properly. If this is skipped, rest of the process will not go right. Alright. What next? We can remove the accented character first. You can see that I have got the accented characters available here. E, A. We are removing this kind of accented characters from the input that we are going to give. We are going to use Unicode data. This is the library that we are going to use for this removal, and it's going to be very simple. How do we do it, sir? Very simple. I have got the code here. Importing Unicode data is the first step, and I have written a very simple function, remove accented chars. That's all. Now we are mentioning the accented char here. You can see that fiancé is the input that I am giving, and out of which I need to remove this E. Now when this accented char method takes this input, it will be able to remove that, and we have mentioned clearly how do we go about it in the code. So once this is run, I am getting fiancé without accented character being included. That's a very simple way of doing it. Now, what do we do next? We are going to remove the special and non-alphanumeric characters. We are going to use RE module in the Python to remove the special characters and numbers from the given input. You can also define a pattern that clearly matches anything that is not an alphanumeric character. So see the code. It's a very simple piece of code that we have written, and for the benefit, I have given the comment lines perfectly. So import RE is the first step. Then we are defining a method or a function to remove the special characters. You can clearly see that we are defining the pattern to match any character that is not a letter, A to Z or A to Z in the uppercase. We have done that. And then we are using re.sub to replace all the non-letter characters with an empty string. That's it. It's a very simple way of doing it. And then I am pushing in an input sample. Hello, world, exclamation mark, welcome to 2024, full stop. Let's clean this, and followed by that, I have got some text. Now, we are going to remove this. We are going to remove the special characters and numbers from the input by passing this input string into the method that we have created. That's all. Once it is done, I get the output, and you could see that here. The original text is hello, world, exclamation mark, welcome to 2024. Let's clean this, some special characters, followed by text. The clean text doesn't have any special character. Numbers are all removed, and that way we got the output. So we have removed the special and non-alphanumeric characters here. Now the next important thing is to getting the uppercase to lowercase converter. Why is this important? What are the things that we get when we go with uppercase to lowercase conversion is to be discussed. We are gaining the consistency first. Converting the text to lowercase really ensures that the words are treated really uniformly. So hello with uppercase H and hello with lowercase h are the same. And we are going to reduce the variability as well. And it makes things very easier for the searching and the retrieval process. We are also getting the token matching much easier. When you go ahead with the tasks like tokenization or keyword extraction, converting the lowercase typically ensures that the tokens like Python with P capital and Python with P lowercase are considered identical. And comes the feature reduction. When you go ahead with the NLP tasks, converting text to lowercase reduces the number of unique tokens. This literally simplifies the feature space and can lead to definite better model performance. Hello and hello, as I told you earlier, both convey the same meaning but are represented differently and are treated as unique words by the encoder. So we can overcome all these problems when you go ahead with converting the uppercase to lowercase. How do we do that? A small piece of code. We are taking a sample text and we are sending it to the method called as text.lower. That's all. So original text against the converted lowercase text. That's it. We get the output and you could see that in front of you. So all these are important and this is going to be very easy for you to. Now we have to remove the punctuation. Yes, it's another common and very important step when you go ahead with text preprocessing. When you go ahead with the tasks like text analysis or NLP, machine learning tasks, you need to go ahead with removing the punctuation and we are going to do that right now. I have taken the sample text here, hello, comma, world, exclamation, welcome to the world of text preprocessing with Python dot, and I closed it. Now text without punctuation is going to be done with text.translate method where we are going to use a simple approach to remove the punctuation and that's how we do it. You can see that in this line where we have done that. We have removed the punctuation and the output has come here without punctuation. All these are easy and I request you to try it out, and once you try it's going to be very easy. Now tokenization is the next one that we need to understand. It's the process where you break down the text into smaller units called tokens, which can be words or phrases or even sentences. The NLTK is a very powerful library which can help you in doing all this nicely. And we are going to see a very small example here. We are going to use the sample text, hello, world, welcome to the world of text preprocessing or processing with Python. NLTK is a great library for NLP tasks. And I have used NLP.tokenize and I have imported word tokenize and sentence tokenization options here. Now I am going to download the NLTK data files here with punkt. NLTK.download punkt is run. For sentence tokenization, I use sent_tokenize and I pass this text as argument. For words tokenization, I pass the text as argument word_tokenize, and that's it. You are seeing everything in front of you. And sentence tokenization is done properly. You could see this here. Word tokenization is done very appropriately and you can see that here, and try this out. You'll be able to understand things better. We can also do this with TensorFlow, tensorflow.keras.preprocessing.text, and from that, if we import text to word sequence, we'll be able to get the tokenization done appropriately also. That's very simple. And stop word removal is the next one that we are going to see. We are going to remove the stop words like the is, the in, and the. All these are going to be removed and it's going to be simple. And you can see that I'm going to use the sample text. NLTK is the leading platform for building Python programs to work with human language data. Now I have downloaded punkt and stop words. Now I have got the text available here. I need to pass it to the word tokenization first, and I'm going to get the list of English stop words here, and I'm going to filter the words here. Word for, word in, word if. All these are going to be removed, and that's it. There I'm going to get the output available for me. You can see that NLTK is a leading platform for building Python programs to work with human language data, and the output has removed the stop words which I have mentioned here clearly. NLTK leading platform building Python programs work human language data. That's all. It's pretty simple and easy for anybody to understand. And finally, it comes the stemming. The stemming is a process of reducing words to their base or root form. Yes, this is very easily done by removing the prefixes and suffixes normally. The goal is to reduce the inflected or derived words to their common base form, which is called as the stem. And this is very useful when you come to NLP tasks because it helps to treat different forms of word. For example, running, runner, ran, all these as the same word. Now we will have a very simple example here, and you can see this, and we are going to use a very simple example, and I'm going to import the Porter stemmer. And NLTK is a leading platform for Python programs to work with human language data. Running, runners and ran are related words. Now I have downloaded PUNKT. I am tokenizing the word. Then I use quote stemmer. That's all. Output is available here. NLTK is a lead platform for building Python to work with human language data, run, runner, ran, or relate word. That's all. We have done the stemming. It's very simple. So try out everything together once and you will be able to understand things better. If you have any questions, please go ahead and ask in the chat. I'll be able to get you a proper reply. Thank you very much.